So remember last time we were looking at reverse chain rule for polynomials, right? And this is not chain rule here. This is just regular old, normal sine x, normal cos x. Okay. So you keep your table going. I'm going to draw myself up a new one. F dash, F, and F5. Okay. So how can we do chain rule? Now, you only do simple ones. Remember, when we were addressing the primitive of something like this, okay, that was fine. When I multiplied by a number like 2, okay, I just had to divide by 2 later on to compensate, right? But we got into trouble if we did something like that. It all just went, it just blew to pieces, okay? So in the same way, when you're thinking about reverse chain rule for trig functions, okay, what you'll find is you'll just have, constant coefficients, basically, okay? So let's think of one. How about sine 2x? Okay, now, it's derivative. Use chain rule, okay? Do the inside, do the outside. What's the inside? It's just 2, right? Then you do the outside, sine turns into cos. No problems. Okay, now, because I multiplied, right? Multiplied by the derivative of the inside when I differentiated. When I anti-differentiate, I ought to expect not multiplication, but division, right? So dividing by 2, so a half, right? And sine came from negative cos, right? So let's slap that minus sign up the front. Now, does it work? Does it work? Should we just try it out quickly? If I were to differentiate this thing, okay, you do the inside, right? So I'm going to multiply by 2. I've got this minus a half floating out there, and then you do the outside. Cos turns into minus sine. And the constant vanishes, right? So cancel, 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 cancel. Looks good, okay? So it works. We're going to divide through by whatever that is instead of multiplying. And just watch out for your signs because like before, things can flip around, okay? So we get rid of this test. What about plus 2x? Actually, let's skip the 2. Let's make it some constant for, let's make it a real number, okay? If I were to differentiate, what would I get? Cos turns into minus sine. So minus a sine ax, okay? So being that I multiplied going this way, I'm going to divide going this way. What did cos come from? Just regular sine, yeah? So 1 over a sine ax, and my constant, okay? Tan's going to work the same. Sec squared is going to work the same. So, for instance, if I had sec squared ax, okay, just follow the pattern. Where would you expect that it came from?
1.
Divide, and sec squared comes from tan, right? So tan ax, actually constant, okay? Okay, now by the way, at least the way I've written it here, maybe I can change this to, you can change this to an A on yours as well. These results are so important, right, that they actually give these to you for free on a little sheet of paper called the table of standard integrals, because later when this is connected to integrals, they give this to you in the exam, in our exams and in the actual HSC.
The Department of Education says here, free cheat sheets.
The Board of Studies says
the
here,
free cheat sheets. The Board of Studies and all
so,
the Department of Education.
Yeah, now, because they give it to you, do you not have to learn this? Answer?
No.
No way, because no one actually looks at the table of standard integrals, because if you don't know the results well enough that you got to go and look at the sheet, then you're probably going to make some errors anyway. I just kind of treat that sheet as a sort of like safety cushion. Generally not good paper plane material because they are laminated, so they sort of they might be sort of decent frisbee material, but anyway, just don't take someone's eye out. Yeah.
What if your function is like
a lot more complicated? Okay, so the short answer is it depends. So for instance, let's do something just a little simpler. Okay, something like that. Okay. Now, we unfortunately we can't just divide through by the 2x, okay? And that was what I was trying to illustrate when we did this one. I think we did that, I think. And we saw what happened. We tried to use reverse chain rule on it and divide it through by 2x, and we found it just blew things apart, okay? It didn't work. So you can't just divide through by actual functions of x. Divide through by constants, no problem. And the reason why is because you can take constants in and out of a derivative or an antiderivative just as you please, okay? If they were to give you a question like this, and eventually you'll meet things like this, what they'll give you is a substitution. There'll be like a part A, and they'll say differentiate, some weird function.
Will they give you one they have to expand?
Sometimes. They'll say differentiate this, and you'll end up at this. They might even say show that the derivative of this is equal to that, okay? And then they'll say, in part B, hence, find the primitive or integrate, whatever you're up to. This, on the basis of the fact that you know it's primitive, is going to look something like this, okay? But we'll deal with those kinds of questions later. Because they're not expecting you to, it's not in a form that you're expected to have memorized, right? Every single one is different. You'll get a new one every single year. It's hard to predict. But we'll do plenty of practice questions. You'll see what it looks like, okay? All right. Does anyone have any questions about any of those results? Yeah. Okay. Yeah, I'll give you the sheet. There are a few other people who are in categories. Okay, yeah, Jesse.
What's the derivative of x squared ax?
2 on a tan. Ooh, hold on. Sec. No, sorry. 2a. 2a. What am I doing? 2a tan ax sec squared ax from memory. I think. Not that it's a particularly useful result, but you can. Yeah, that's exactly what it is. That's all it is. Okay.